they'll hear me.
And even the one week that it happened, we didn't have money there. So
All right. Yesterday at the end of class, we were discussing how to find MS in lab. So imagine you have a plane and you have this angle. We'll figure out how to get it in a minute. And if we do know that angle, we're in good shape because we know that if the object is still and not moving, these forces are balanced. So we have weight sine theta, and we decided going down was negative, up was positive. This was mk cosine theta, weight cosine theta. So if we were adding those forces, and this is already in your notes, so just find it. mk weight cosine theta is positive minus weight sine theta equals 0, because the sum of the forces is ma, but there's no acceleration, the object is still. Oh, yes, thank you. I just made that point. So I'm so used to writing mk, thank you. So now we will solve for ms, u sub s, and we move weight sine theta over to the right from the left and divide by the coefficient of ms. Weights cancel, and we got sine over cosine. And just as the bell rang, I said, what is sine theta over cosine theta? Oh, mathematicians, it's equal to the tangent. So that is a nifty tool if you know theta. So I give you the inclined plane, and you know theta, and you just find the tangent of theta. That is ms. Very, very handy tool. However, as I said, Miss Grace McManus won't give us the protractor today. So what's another way in lab we can find it? O-Tree students. So it turns out when I give you the board, you're going to know its length, and you can measure the height at which the board is. So what trig function will come out and help us find this angle? What is opposite over hypotenuse?
Tangent. I mean, no.
Do you have a test today? All right, let's work out these kinks.
It's not on trig identity.
Okay.
It's on taking a derivative. That's it.
Oh, that's the easy part.
Yeah,
Right.
it's easy.
Opposite over hypotenuse is
I was
the
thinking
sine
adjacent.
function. So you're going to know this number, you're going to know height, you're going to know the length, because I'm going to give you a meter stick, and you're going to measure this, and you're going to measure that. So if you divide this quantity, Alex, if you divide this quantity by this quantity, h over L, you'll have a number. So then the calculator will know what angle has that as its sine. Suppose this is 1 meter long and half a meter high. Let's just pretend that. So that becomes 0.5. And the calculator can tell you what angle has this as its sine function. And so if you're in degrees, then what angle has the sine of 0.5? Some of you are fresher on this than others. Think of your unit circle. What angle has what angle has 1/2 as its sine? What is it?
5 or 6.
Okay,
Or 30, that's 30.
I'll say 30 for us. So you have to, on your calculator, if it doesn't come out to be on your unit circle, which I doubt that it will, sine inverse of whatever number you have here, h over L, that's what that number is going to be, the height divided by the length, is going to give you the angle. So then what do you do with the angle? To get ms, you take the tangent of it. So you'll have to do the inverse sine, then the tangent. It's a very quick lab. So let's go divide into 3 groups. So I'll do differently than the way you're sitting, so for a change. And I think, what page is that lab one? Let's turn to the page while we're still in video. Lab page. Somewhere in, if no one could find it, it's in Unit 6, Chap Mod 6, in the green. I found it, page 198. I actually jotted it down. So those in video land, on page 198, if you would check that out, you'll be seeing what we're doing today. Basically, we'll form an inclined plane and put an object on it, raise the plane until it just starts to move, and find MS or MK at that point, whatever it asks us to do, using these tools, which I'll leave on the board. All right, let's turn off the video, and we will come back and show you our lab in motion in a little bit. See you then. All right.